Hello guys, welcome back to the new project of CodingPy. This is project 10 out of 50 plus AI project. In this project I will show you that how you can apply YOLOv5 object detection on top of recorded videos. So if you were new to our YouTube channel, then please hit like and subscribe button before you miss any update. And without wasting more time, let's get started. So here as you can see, I used to install all the required libraries which is necessary for this project, which include Gradio, Torch Vision, Torch Audio, OpenCV Python, Ultralytics and FFmpeg Python. And in my case it is already installed, so it says requirement already satisfied. Now quickly I used to move on to the next step, where I import all the required libraries which is necessary for this project, which includes Gradio as GR for creating user interface, Torch is used for loading the YOLOv5 model, and CV2 is basically used for video processing, and if we're gonna talk about OS, it is basically used for file handling. Now quickly I used to move on to the next step, where we can load the pre-trained model, that is YOLOv5. So first I used to define a variable called model, then with the usage of torch.hub.load function, where I used to pass ultralytics/YOLOv5, YOLOv5s. Here torch.hub is a PyTorch utilities that allows users to load model, dataset and other resources directly from GitHub repositories. So inside the load function, ultralytics/YOLOv5 is a repository path where YOLOv5 model is hosted, and YOLOv5s is the smallest variant of YOLOv5 model. And if we're gonna talk about it, it is a lightweight pre-trained model that is used for object detection and commonly used for lightweight application. Now quickly I used to move on to the next step, where I used to define object detection function. Here as you can see, with the usage of def keyword, I used to define a function called object detection on video, where I pass video_path as parameter. This function encapsulates the logic for performing object detection on top of videos. Next, with the usage of CV2, where I call a class video capture, where I pass video_path. This line of code open the video file is specified by video_path, then store it to the cap variable. This cap object is used to read frame from the videos. Next, with the usage of conditional statement, I used to check if video is opened or not, and if it is not, then it returns a message that is error could not open video. This line of code ensures that the program handle cases like video file is missing or corrupted. This will play a very crucial role to prevent runtime error. Next, I want the video properties like frame width, frame height and FPS. And with the usage of cap.get function, I pass cv2.cap_prop_frame_width. I used to convert it into a numerical format with the usage of int and store it to the frame_width. Same I used to perform on top of frame_height and FPS. These properties are quite important in order to configure the output video file, so it matches the input video resolution and frame rate. So for output file, first I used to define a variable called output_file and specify their name output.mp4. Then with the usage of CV2 video writer class, output_file cv2.videowriter_4cc, where I pass mp4, fps, and inside the round bracket I used to pass frame width and frame height. Now quickly I used to store it to the out variable. Next I used to count the total number of persons, so for that I used to define a variable called total_people_count variable and store 0 to it. This variable accumulates the count of peoples across all frames. Next, with the usage of while loop, I used to process video frame by frame. So inside the while loop I used to call cap.read function. This function is used to read the next frame from the video. Then I used to restore it to their corresponding variable, that is read and frame. Read basically store a boolean indicating whether a frame successfully read or not, and frame contain the image data of current frame. Then with the usage of conditional statement, I used to break the loop if the frame is not successfully read. And finally, in order to detect object, I used to pass frame inside the model object and store it to the result variable. Next I used to extract detected class. So for this, result.xywh with index 0, which contain the bounding boxes and class IDs, of detected objects, and again adding index with -1 used to select the last column which contain the class IDs. Then with the usage of CPU.numpy, I used to convert tensor into numpy array for fast processing, then store it to the detected underscore class variable. This line of code acts as a filter which count a specific object in a frame. Next, I used to count the number of peoples in the current frame and then add it to the total count. Then with the usage of condition detected underscore classes equal to 0, perform checks on frame that detected objects are peoples. And with the usage of sum function, I used to count the number of true values and store it to the people underscore in underscore frame variable. Then I used to add it to the total underscore people underscore count variable. So this line of code keeps track total number of peoples detected across all frames. Next, I used to render detection on top of frame. So for that, the usage of results.render function with index 0 overlay the detected object on the current frames. Then store it to the frame variable. This line of code visualize the detection result and make it easier to understand what model actually detected. Next, with the usage of out.write function where I used to pass frame, this line of code write the processed frame to the output video file. So this will generate output video with detected result. And finally, I used to release the video with the usage of cap.release function, and same I used to perform on top of output video. This line of code ensured that proper cleanup after processing the video. Next, I used to convert a video to a web-friendly format using ffmpeg. Here, as you can see, with the usage of os.system, I used to pass fmpeg on top of output underscore video file. Finally, in return statement, I used to print total people detected. So I passed total underscore people underscore count inside the curly braces. Quickly, I used to move on to the final step where I used to create user interface using Gradio. And here, as you can see, first I used to define a variable called iFace, and with the usage of gr, I used to call interface class. Inside that class, I used to define a variable called fn. I used to call a function object detection on video. Next, I used to define input as variable. With the usage of gr.video, I used to take video as input. Next, I used to define output as variable, and I used to create a text box with the usage of gr.textbox. Here I release processed video with the usage of gr.video. Next, I used to define title and description of this project. Finally, with the usage of iFace.launch function, I used to deploy code on Gradio. And as soon as I run the code, I will get the public URL. After clicking on it, I will redirect to the public user interface. And here, as you can see, the entire user interface of this project. Now quickly, I used to upload a recorded video. After that, I used to click on submit button. As soon as I click on submit, I will get the predicted result. And here, as you can see, the total number of detected peoples. Also, you may notice in output video, YOLOv5 not only detect person but also detect what they are carrying. Hope this video is informative. Please do like, share and subscribe for more upcoming projects.